Hello from the Forcetronics YouTube channel. Welcome to creating a sensor network that connects to the cloud. And this is part 2 of a 3-part series. If you haven't seen part 1 yet, I recommend you watch that one first. And let's get started with part 2. Okay, this is just a reminder of our network architecture. In this example, I'm just showing, 3 sensor nodes or 3 network nodes. Of course, you can have a lot more. We're just using 3 for this example. One thing I want to mention that someone commented over Twitter to me after part 1 is why we're using the cloud. And I talk about this in the IoT series, which I refer you to in part 1. Why are we using the cloud? You could just connect directly to the Maker 1000 and grab the data. You can do that on your local network, meaning your home router network or your home Wi-Fi router network, real easily. But if you go outside your router network, it gets a little more difficult to connect to it because your router has a firewall. But there is things you can do in your router, such as port forwarding, that allows you to sort of get around the firewall so you could connect to the Arduino Maker 1000. So why do we need the cloud? Well, the cloud's really useful if, let's say, for instance, you want to store a lot of data and you don't want to store it all in the Maker 1000 because you want to store megabytes of data. That's where the cloud comes in good use. Also, if you want to have a group of people access the cloud from Android apps, let's say, you have a shared garden or a shared indoor garden, you want everybody that's part of the garden to access it. It's much easier if you have the data on the cloud for others to access it rather than having everybody sort of try to come in from the network. Another reason is, let's say you want to create a product out of this. If you want to deploy this as a product, or you just want to deploy it in multiple locations and you don't want to have the users configure the router, it's much easier to just send that data to the cloud. So once again, you can do it directly connecting to the Maker 1000, and I talk about that in the IoT series, but the cloud is a nice intermediary, so you don't have to have you don't have to worry about poking holes in a firewall and getting through that. Okay, I showed this in part 1. I'm just showing the hardware I'm using. Once again, these wireless flex nodes, I sell them at forcetronics.com. They have everything you need on them. You can just use any AVR Arduino though with a NRF24 L01 transceiver. Here's my Maker 1000 connected to the same transceiver. This is my coordinator. These are my nodes. Let's talk about what we're going to do in part 2. So in part 2, we're going to add timestamps to our data from our sensors, because right now we're just grabbing sensor data, we send it to the cloud. The cloud actually timestamps it for us, but we're going to do the timestamps right on the Maker 1000 so they're more accurate. We don't have to worry about network delay. And so how we're going to do that is, once the Maker 1000 turns on and first connects to Wi-Fi, it's going to go to the internet, grab the time, use that to set the real-time clock that's on the SAM-D21 MCU, which is on the Maker 1000, and then we can use that real-time clock to timestamp our sensor data. We're also going to add capability to monitor the battery level of the nodes. Once again, the code for the nodes, which I went over in the wireless sensor network series, that already tracks the battery. All we're doing here is we're reporting that battery data now to the cloud. Then for part 2, we're also adding, I'll say, error checks to make sure Wi-Fi is still connected. Because in the first part, I just connect to Wi-Fi and I just pretend like we'll never lose connection. But every time before I post to the cloud, I'm going to make sure the connection's there. If not, I'm going to try to reconnect. And then finally, I talked about last time how the font library that SparkFun made is not really compatible with the Maker 1000. So what I did last time was I just pulled some functions from that library, had it in with my code. Now I'm going to make it back into a library that works with the Maker 1000. That way I just sort of abstract some of that code. And then, as always, all my projects are open source, so I'll have all the code on this GitHub link. And if you don't want to try and type in this link, you can just search GitHub and Forcetronics and you'll see my projects come up. Okay, let's see the part 2 of the network in action. Okay, here you can see the serial monitor, which is just displaying the data. A lot of it's the same thing you saw in part 1. We say the node number, we say the temperature, and then we say the status of the battery. One of the different things though is you can see the timestamps. So the timestamps in UTC time, and it has a date as well. And we'll talk about how we do that in the code. And once again, I just have the nodes rotating every minute. They're reporting sensor data or temperature data. Okay, here is the font cloud that's capturing the data. And you can see I changed things around. In part one, I had one for each node, a field for each node. Here, I'm capturing each node separately because all the nodes aren't reporting in at the same time. So here I report the battery status, the date and timestamp, the node number, and the temperature. And remember, font doesn't handle floats well, so I'm multiplying the temperature by 10. Then when we view it again later in part 3, we'll then again divide it by 10 so we can see temperature with the precision of 1 decimal point. Now, as I mentioned before, font's great because it timestamps data, but a lot of times the timestamps, because of network delay, don't match up. So I added timestamps just to have more accurate timing. So let's see if we can provide an example. A lot of these are already pretty close. The font shows a higher level of precision in the timestamps, but I mean, here's an example. So this is 55 seconds, and this one right here is 56 seconds. So there is definitely a network lag. Now, right now it's nighttime here, and there's not a lot going on in my network, so the lag isn't as bad. Depending on your network speed and the traffic on the network, these times can be a couple seconds off. So that's why I added the timestamps. Also, depending on your exact application, because this is what this is meant to be an example, and you're going to want to tune it for your exact application. But let's say your MKR 1000 is running off a battery and you're trying to conserve battery life. In that case, you don't want to be reporting data to the cloud a lot. So you may want to create an array that holds, 10 or 20 or 30 readings, have all those readings timestamped, and then send all that data to the cloud at once. But once again, timestamps add a little more level of precision to the time measurement of the sensor data. Okay, with that, we looked at it in action. We looked at the data on font. Let's look at some of the changes to the code. Okay, the first big change is this library, and you can see I have it locally in this sketch folder. I named the library font mkr1k.h, and once again I have it in quotations because I have it locally, so you can see it here in the same sketch folder. I'm actually not going to go through it. You can check it out yourself, but once again it just adds a little abstraction to some of the string functions that are used to configure the strings to talk to the internet, or talk to the cloud, I should say. Okay, all this is the same, so I'm not going to cover that. Where is the first major difference? Here I created a function that does the connection to Wi-Fi to further abstract that from the setup code. I then create a Wi-Fi client, and I use that client to grab the server time. So I think that's one of the first major changes. So let's go down to that. So here it is, and I leveraged this from an Arduino playground post by Francisco, and I'm not going to try and say his last name, but he does a lot of good code, and I leveraged this from his code. So basically what he's doing, and I thought this was pretty clever, and there's more than one way to get time from the internet, but he essentially uses a website, and you can put any website in here. I just used the example website that he has, and he makes an empty call to a server. And what he's basically saying is, in the HTTP 1.1 bylaws, or I guess standards, if you make a call and you return an error, you have to give the date and the time on that reply packet. So he basically sends an empty call to a server and grabs the time and the date like that. So that's what's happening in this code. And once again, we're using a client because we're a client. We're trying to connect to a server. We pass that object in by reference. We then make the call. We set the client timeout. We wait for the data to come in. Then basically we're going to parse through that data, that packet. And if you want to check out the packet, you could always do a serial print to see if you wanted to see the whole packet. But we parse through it to grab the day. I then use the real-time clock library. Maybe I should have mentioned that there's a library. It's called RTC0, real-time clock, and they call it 0 because it was originally made for the Arduino 0, but it works on the Maker 1000, and it's basically controls the real-time clock. So we use this data from the server, to get the day. We parse the data, grab the day, we set the real-time clock, date. We go through the data to grab the month. The month is shown as a 3-letter, which we have to convert to a digit later on. We grab the year. I turn the year into a 2-digit year, not the whole 2016. We set it on the real-time clock. We grab the hour, the minute, the second, so on and so forth. Then right here, we're just going through a large switch case configuration to turn the 3-letter month into a digit month. So February's 2, September's 9, so on and so forth. Then once we have all the fields set for the RTC, we're done. We kill the client, and now our MKR 1000 has an accurate time, so we can timestamp our data. So I'll just show here. Here I have a function called get date and time, and I'll show that function, but that's what I'm printing out to the serial monitor. I changed the post to font function around, so I feed in all the data, the header or the node number, the temperature, the time and date, and the battery status. Here is the function where I configure the time and date. So I just turned it into a real long string. So you can sort of, if you want to change around how you configure the time and date, you would just sort of change this function around. Here's my post to font. Now I have all these different arguments. You can see my new fields because now I have node, temp. I thought this said date. I think I meant to say date, but I named it data tstamp. And then battery status. So that is the major changes. Oh, I'll mention this one as well. Here I do a connection check. And if I'm not connected, I attempt to reconnect. And while I'm reconnecting, I turn on the LED, and then once I reconnect, I turn off the LED. So if you notice the LED is stuck on and it's not going off, then that probably means you're not connecting to Wi-Fi. Okay, that is it for part 2. And then in part 3, things get more exciting because we're going to be grabbing the sensor data from the web, and then we're also going to look at an Android app for us to read our sensor data from the cloud. If you have anything to add, any comments to build on part 2, please use the comment section, and thank you for watching.